Alright, so we should be good. Yes, indeed, streaming is possible. Alright, okay. Back to coding. Because we were so close. So now is complaining cannot borrow environment because it was also borrowed as immutable. Which means that we just need to say let memory equals environment data. Then can I say memory.view here? No. If I say clone, does that fix the issue? It does. So we're banking on a lot. We're banking on a lot that you can actually clone that and it still references the same thing. But yeah, theoretically, all of this now would work if we were to say run it.
And theoretically, your mom.
What?
And theoretically, your mom.
No. Go away. Yep, error opening file. Yep. Panic. So I need to copy. So there's our executable. So from our test scripts, let's copy over U2 into here. And now if we run this again, we still aren't able to load it. Let's look at the console. No such file or directory. Wait a second. The run... I'm gonna do something spicy. We're gonna set the run directory to be the same as the output of the WASM files. A bin target must be available for cargo run. Oh, okay. So I still need to set this to be the scripting runtime. Main panic called unwrap at No, of course not. Okay, let's set this to scripting runtime to be our run directory. This runs. So if we put our two WASM files in our scripting runtime folder, do they then become available? So we are now, okay, so we're now panicking here instead, which is better, which means we're actually opening up the module and everything. Let's see what errors we have to deal with. If instance is error, was unable to instantiate module. Instantiation error does not implement display. Okay. Like that. What does this do? That doesn't do anything. The debug output of the argument. Okay. We'll go with it. And we'll say let instance equals wrap here. Oh. Let's try this again. This is true. Was unable to instantiate module. Link import BraneEngine. Extern BraneEngine print. Unknown import. Takes an I32 and results. Okay. So it wasn't able to find the print. So the question is it a problem with the actual import, or is it that the module isn't finding the import? I think it's that the module isn't finding the import. However, okay, it just paused there. Unable to instantiate mod. Okay, so same error regardless of what I put here. Which makes me wonder. Import BraneEngine. Wait a second. Wait a second. Wasm import module BraneEngine. So if I put these into a BraneEngine here, because this wasn't doing anything before. However, this might. What do I do to combat depression? I code. If you go over to the Twitch stream version of this that didn't get reset, like we're currently at 5 hours. That's what I do. There we go. Look at that. It works. Okay. That was a very abrupt, it just works now. Streaming is possible. Code is also possible. Indeed. So I do like that this is actually working now. That's very nice. Okay, so let's copy over the rest of my stuff from the C++ version of this. Now let's collapse that panel so we have more screen real estate. It's all about real estate. That has been my experience. Okay, so that's all our imports. Imports are fine. We did all the imports. So let's now also, let's make this module uno. We also need a module dos. Okay. So now if we do instance 2 for all of these, we now have all the stuff for instance 2. So we first call test function, that's all working fine. Then we'll do the do we go straight from test? Oh no, we test the extern call. So let's do that. So instance let test extern call. So this is test external function. Okay, so we're not namespace clashing right now, or whatever you want to call that. I came up with that term on the fly. So instance, see, we want, wait, where is it getting regular instance from? Ah, there it is. Instance 2.exports.get function, and then test extern call. We'll just call unwrap on this. Test code. Then just override result. Test extern call. Reference the store. And do we pass any arguments into here? Arguments are empty, so we'll just pass in a reference to an empty slice. Look at this. Rust. 3 lines of code. C++. 13 lines of code, 14 lines of code. That's how you can tell that this is a Rust library. And this was the C bindings for the Rust library. We'll call unwrap on those values, because the function call will never fail. That'll never happen. It's impossible. Unthinkable. And now the component, the function calls that probably will fail. Wasm pointer. If I say res vec, it's probably going to claim it's been consumed. No, actually, it takes a reference. Oh, right, because we need to actually get an index of the vector. Okay, there isn't a wasm pointer as one of our options. So we probably have to do something weird. Actually, we don't. We can just pass the i32 back in. We're gonna say let test component ref equal nothing. And then let create test component is going to be equal to, and then did I put this in? Okay, it's currently in instance 1. Exports get function create test component. Okay. See, test component ref is going to be equal to create test component call all of the unwrap calls, all of them. Not even going to call expect. We're just going to go straight to unwrap. This is going to crash and I have no idea why. Sorry, no, it's not going to crash. Never crashes. My code is always perfect. This is true. This is true. You know, by calling this, I am saying I am fine with my program crashing here. I'm very confident it's not going to crash here. No possible way it could crash here. And then when that assumption is inevitably wrong because I'm calling unwrap on every single one of these lines of codes, sometimes multiple times, code is perfect. Never gonna crash. You guys can just sit here and go, right, yeah, we believe you. We believe you. So yeah, this is probably a time when we want to actually deal with a little bit of error checking here. This returns a result. Okay. Okay. Well, this one doesn't have as much of a chance of crashing. Undefined language, undefined behavior. I will have you know that time that I am dereferencing a stack allocated but uninitialized value, that's actually the way that I'm randomly generating numbers. It is completely, you know, it's in the spec. It's supposed to be undefined. Okay, test component ref. Okay, we should probably actually define this to something just in case we do get an invalid value. Though, I'm gonna set it to -1, that way it's actually invalid. Test component ref is equal to result dot okay, yeah, we could just say to-vec as a point, no, not as pointer. I don't know, you're throwing a lot of acronyms at me right now. Not quite sure what most of those are, to be honest. Back. And it even lets you unwrap at the same time. Oh. Pringles. Understood. Realized I've had Copilot off this entire time. There we go. It helps a lot with this. Not so much with actually getting stuff to work. Cannot assign to... Oh, okay. Sorry, Rust. Oh. Undefined behavior, or not undefined behavior? That is the question. It is indeed the question. It guessed correctly. I'm suspicious that it guessed that correctly. I guess it's looking at this file too, and somehow figuring out the pattern. Anyway, it did, however, fail to realize that test component access is in fact in instance 2. Shame upon you, Copilot. You did not increment a singular number. It doesn't actually we have to be a little bit fancy here. Let's grab our test component code here. And then we're gonna say, oh, what's the thing to make it? 1 second. We're going to go to API source macros. What was the thing I added to make it reproduce C. We just need to throw that on here. And now we can actually use this, as it is in the same data structure as C. Indeed. So the idea is that I want to make the bind gen for actually using the engine super simple. So for it's an entity component system. So for functions that you would call from the engine, otherwise known as systems, you just plop system on the function and it automatically does all the extern C stuff. And I can also scan the file looking for these macros with a different tool to generate metadata about the thing. So if, let's say we want this system to happen after a different system, to use like a really common Unity example, even though I'm going to come up with something different for that, it's going to be a lot better than just saying, make sure it's after this system. I'm going to have a much better system for that. Node editor graph is my current thing for that. Anyway, we could say after test function or something like that. And then I would be able to scan the file, look for that, parse it out, boom. So that's the current plan of the interface for this. And then component, same thing, grab component, define it. When I do this, I actually also bind gen create constructors, copiers, all that sort of stuff, which we'll hopefully get to try out soon if all of this goes according to plan. Yeah. So yes, we want to pass in the value i32 test component ref. That is the correct code. And now let test component equal wasm pointer. Can I create new? Test component ref as u32. Oh. Oh, macros have been amazing. Like, I'm decently good at C++ macros and templates. And I've pulled off some magic with them, but Rust is just like, okay, so other languages, they have this weird format for everything, right? And we have that too. However, can I interest you in a raw token stream? You can do whatever you want with it. Yes, please give that to me immediately. Oh, it's amazing. So I think we have to define the type for this. Wasm pointer, and then we want this to be a pointer to test component. Can we just do that? Is it that easy? And then we can dereference this. It depends on the language. C#, yes. Absolutely hate C#'s generics, because they do a very similar thing to Rust with traits, where you can like say where this type implements these traits. However, with C#, you're not able to call overrides of functions with different parameters, because it's like, oh no, I don't know which override of this function to use because I don't know what the type is, so it just errors out. So you're not able to do the C++ thing where you just say, okay, it'll just generate copies of the function, which I guess in Rust you don't have that problem because you can't make overrides of the same function with different parameters, but I've been having to deal with C# generics a lot recently, creating like a serializer and deserializer. It's a pain in the ass. And then some languages don't have macros, and then other ones do. So we want a view, and the view that we want is main memory, view, and then we pass in the mutable store into that. Then we'll pass a reference to this. Why are you complaining? Value type and copy. C++ 29. That's almost like reminds me of the Super Smash Brothers 20XX meme a little bit. C++ 20XX. Is it possible to get a raw reference to whatever's in here so I don't have to copy it out? Even if it's unsafe. Let's write some unsafe Rust code. Able to get offset, add offset, and all that good stuff. Wait a second. Trait bounds are not specified. Due to unspecified. Disk component, value type, and copy. So if I just go up here and say derive at copy and clone, does this suddenly magically work? Value type. Okay. Value type. Rust value type. I'm guessing it has to be like a simple value. So here in print, we say text pointer read. Okay. Let's just do a Google search. Wasamer. Bane. I ate a pizza recently with a lot of jalapenos on it, and I think I still have maybe slight traces of that on my fingers. And my eyes still, yeah. Eye irritated. Wasmer read struct. So yep, reproduce C, that makes sense. Yep. Okay, we'll just look at memory pointers again. Pointer, dref. Okay. WASM reference. A reference to the value in WASM memory. A value type trait which guarantees that reading and writing such a value to untrusted memory is safe. Can I just say derive value type? I can. It's that easy. And then, what is the value of this test component? Oh, my editor's taking some time to catch up. Okay. We'll close out some windows, clear up some RAM for it. Or... oh, okay, so the unwrap call was unnecessary. Good to know. Dot... so... how do I interact with the values? That's the main question I have. Didn't that error the derive? Oh, so it did. Could not find Wasmer types in the list of imported crates. Okay. Value type is defined multiple times. Oh, because it's up here. Wasmer types. Maybe I need to directly import this crate? Possibly. Add Wasmer types. Okay, there is actually a crate. So we'll see once this all compiles. Cannot find derive macro value type in the scope. Consider importing it. It's only a trait without a derive macro. Okay. If we go to the A value type is a type that is always valid and may be safely copied. To maintain safety, a type which implements this trait must be valid for all bit patterns. This means it cannot contain enums, bools, references, etc. However, a bool is not a value type because any bit patterns other than 0 or 1 are invalid. Fair. So if I manually implement it, I'm manually messing with stuff. Okay. So basically, that is a red herring dead end. We can't... basically, it would be unsafe code. Which is fair, because we can't know what that memory it is, as it is like a third party. However, we could do read. And get a copy, I think. But it's trait bound. So value type must still be specified. Even though, wasm pointer, deref read, write, slice. What is a wasm access then? I thought it was easy. Let me guess, trait not implemented? Yup, trait not implemented. If I borrow this... Okay, never mind, it's red herring me. So, what if... instead of test component, so instead of bool, we could say this is a unsigned 8-bit integer. And then would it then dang it, what was the name of the function? What was the name of the function? Was it deref? I think it was deref. Well, one of them was deref. Or read. It doesn't like everything I'm trying to do. Alright. Thank you for sticking around, though. It's appreciated. Could we create a slice of unsigned 8-bit? Is there a rust size of? Okay, so it's standard mem size underscore of. Actually, for slices, isn't it a something like that? Okay. Now, I can say let test component equal test component dot access. Oh, we want view. So we say main memory dot view like that. Oh, right. And this has to be a reference. Dot unwrap. Dropped while borrowed. Okay. Easy enough to combat. Cool. So we now have an array. Or a slice, sorry. Well, it is an array, let's be completely honest. I can't believe this worked, though. We are going to commit sin. Let A equal test So A is just going to be 0. And how do you do casts in Rust? Casts. Oh, so you just say as? That's right. I remember now. Let's go as bool. Though, thinking about it, we could say as ref dot as pointer as test component pointer. Let's see, what's this complaining about? Expression expected. Oh. Is a mutable test component pointer. Ah, this goes against all that Rust stands for. Print line test component is let's say test component values A equals that. Oh, no. Test component, all of those. Though, Copilot, I will disagree with you. I want to use the arrow operator. Wait a second. Can you not arrow operator? Oh, you can just... This component's right. Okay. Well. We'll go with that then. Thank you for the follow. I've been forgetting to thank people for follows, so thank you to the others who have followed this string. I can't speak. Thank you. It is appreciated. Don't know why you would follow while I'm writing this abomination, though. Does yes. So we'll just do that. Test component or create test component. Returned that. And then I am actually going to copy this abomination. This old abomination. Over to here. Except for that print. Yep, I know there's a duplicate code fragment. It is intentional. So, you want to see some magic smoke come out of my computer? There we go. There's our first panic. And it's all the way down here. So test component access is what's throwing the error. Oh, it's just straight up getting the function. That's a little bit of a letdown. I was expecting for a more dramatic error, like for the 30th time, you may not use WebAssembly this way. Something like that. Okay, so that is the name of the function. Go to console. Missing test component access. But look at this, even our test component, like all these creation stuff work. So instance 2 is equal to, there it is. We were accidentally creating 2 instances of module 1. So let's try that again, where we actually attempt to call this on module 2. Another panic. It's still when we try to get the function. All right. So we do actually load module 2 from Wasm Crate. Then we create this instance 2 with module 2. Test function returned on test extern call. Wasn't that working before? Oh, I accidentally changed this to exports 2. We want it to be 1. And then create test component. Okay, so it's a good thing that one threw an error because that was blatantly wrong. Okay, it's working. It's working! It's working! Yeah. So, for reference, since we have a lot more people watching the stream, and I need to give all of you context for what has just occurred. For real this time, we're actually not exploiting a bug in the runtime this time to get it working. This time, I think it's actually working. What we're doing is we're compiling 2 different WASM binaries from Rust. One of them, this is our first test script. We define a couple different functions, most of which we're currently not using, but we import 2 functions. One of them is a test of printing out to the console. The others are just like, okay, can we call a function from the host operating system? Which both of these do. And also, can we create a pointer to a struct? And then can we pass that struct around to other modules? So we create the component, this component, in this WASM binary, then over here in this WASM binary that opened up in a different window pane for some reason. Curse my spicy pizza. I love my spicy pizza, but I got spicy stuff in my eye right now. This binary then reads the component. You can tell it's a different binary because I had to import I had to copy the struct code. But yeah, we then we get a pointer to the test component, and we dereference our raw pointer. Actually, this is a good thing to wonder. Can we get away with just making this a mutable reference and avoid any unsafe code whatsoever? I'm going to write some BindGen stuff on the actual, whatchamacallit, these things, the macros, so that we can pass other types. Like, we'll actually have a string type that we can BindGen to and from the runtime and whatnot. So that will be important. But yeah, we don't have to check any of this anymore. Expected mutable test component, found test component. Oh, you can dereference components. All right, so that is our safe rust version of this function. Are we able to just straight up compile it? So here's the compilation script. We just run that. Let's copy over. It's only crate 2 this time. All right. Let's test it. Okay, so that works just fine. That's good to know. We can pass assumed to be safe references to our runtime, and we don't have to use pointers for absolutely everything. That's actually really good to know. Like this. Well, we do need to call into raw here just to make sure that we actually lose the reference to it, or the memory forgets about it, essentially. Memory leak. Alright, so do I want to try to do anything more this stream? Or do I sign off? This is the question. Because now I would basically start on what I wanted to do this stream, which was start actually implementing a pseudo ECS runtime of calling functions and whatnot, before figuring out how to integrate this with the rest of the engine. However, I spent all of today trying to figure out how do we actually load modules the correct way, which we are now doing. Yeah. So I think I'm going to end the stream here. And then next weekend we'll come back and we'll see if I have any time this week to work on it a little bit more. But next week we should actually be implementing a ECS runtime with this. Because we have all we need. We can call functions, pass around pointers, whatnot, between different modules, and it all just works. So yeah. That's all for today. I'll see you next time.